Hey guys, so this is your helpful hint video for your free response questions for this week. Just a reminder, you will be graded on accuracy. Now I'm not going to be doing these problems for you, but I'll do problems that are just like them. Okay, so let's go ahead and begin here. The first question is asking you to find C prime of 4 and interpret what that means in the context of the problem. Your estimate is worth 1 point, your interpretation is worth 1 point, and the interpretation should include units of input, units of output, and the context of the problem. So let's go ahead and take a look at an example that's kind of like this. So I'll have you guys check out 2018 free response question A for number 4 here. It says the height of a tree at time t is given by a twice differentiable function h, where h is measured in meters, t is measured in years, and selected values of h are given in the table above. So it says in part A, use the data in the table to estimate h prime of 6, and then using the correct units, interpret the meaning of this in the context of the problem. So that's exactly what we're going to be doing. This is going to be worth 2 points. So what this represents is an instantaneous rate of change. Now, we're not going to be able to do that anytime you have a table of values here in this case because we have h values, not h prime values. So what we're going to do is we're going to find the average rate of change between the two values of t that are closest to 6. The two values of t that are closest to 6 are 5 and 7. So what we're going to do is we're going to find the average rate of change between those two values of t. So h prime of 6 is approximately going to be equal to h of 7 minus h of 5 over 7 minus 5, which is going to be 11 minus 6 is 5, and 7 minus 5 is 2. So we have 5 over 2. Now that's only part of the problem there. The rest of what we need to do is we need to be able to interpret this in the context of the problem. Okay. So first of all, notice the top, 11 and 6, those are meters. So this is about meters. And then 7 and 5, which came from the bottom and gave us 2, 7 and 5 were year values, so those are years. So what we have here is 5 over 2 meters per year, or you could say 2.5 meters per year. Okay, so now if I wanted to interpret this in the context, you have to include 3 things. Just a sec. So we want to include our input units. Those are the numbers that we plug in, and that 6 represents a time value. So my input units are years. We want to include output units. My outputs was the answer that I got. That was in meters per year. So we had at year 6, and we had 2.5 meters per year. And the context is about the height of a tree over time. So how would we interpret this? We would say that h prime of 6 represents the fact that the tree's height is changing, or I guess we could say increasing because it was a positive value, is increasing at a rate of 2.5 meters per year when t equals 6 years. Okay, so in that one expression right there, we have the context, talking about the tree's height increasing. We have the output units and we have the input units. That's a proper explanation of what a thing represents. So when they ask you to represent what something represents or explain what something represents, that's how you do it. So in number 2, they're asking us to calculate the integral of c prime of t and then interpret what that represents in the context of the problem. Remember, once again, your answer is worth 1 point and the interpretation is worth 1 point, and we should have input units, output units, and context once again. So a good problem that matches this one is the 2005 number C, or letter C. What we have here is we have a metal wire and it's being heated on one end, and as we get further and further away from the end that's being heated, we have the temperature decreasing over time. Okay, and so the question here is they want us to find the integral of t prime of x dx on the interval from 0 to 8. They want us to tell the units of measure and find that, and then of course explain what it means in the context of the problem. So well, this is a fundamental theorem of calculus problem. Okay. So if I'm integrating a derivative, when you integrate a derivative, you just end up with the original function. Now, since it's a definite integral, we're going to plug in the upper limit and the lower limit to the antiderivative there. And then from there, we're just going to look at the table values. T of 8 is 55, and T of 0 is 100. And that is going to come up to be a value of negative 45. But a value of negative 45 what? Well, 55 and 100, both of those are temperature values. Those are degrees Celsius. So what this basically means is that on the distance interval from 0 centimeters to 8 centimeters, the temperature decreases by 45 degrees. And so once again, there's your context. So we have our input units. Our input units are, in this case, the 0 and the 8, which is centimeters. We have our output unit, which is degrees Celsius. And the context is about the heat of the wire over that distance. So let's go ahead and interpret that really quick. Okay, so the temperature of the wire decreased by 45 degrees Celsius over the distance of 0 to 8 centimeters. And there you guys go. So we have our context, we have our output units, and our input units. So for our next question here, it says, use the table above to calculate this. So this is a weird thing because you'll notice that what they've done here is they've changed the inside here a little bit. So for this particular problem, I'm not going to do an entire problem, but I'll just kind of get you started. So suppose that I'd given you guys something like this. Right? Well, what we want to do is we want to get rid of this inside function here, that t minus 2, and we want just to be a t so we can handle it the same way that we did number 2. That's the basic idea. So the way we're going to do that is with some u substitution. So I'm going to take this expression here and I'm going to say that that's u. I'm going to take the derivative of that with respect to x. We're going to get dx by itself. And then we're going to come back up here and we're going to rewrite this integral. So now it's going to be f of u. And we're going to replace the dx with du over 4, but I'm going to go ahead and put that over 4 in the front. Also, we need to change our limits. Okay, so when x equals 2, if we plug in 2 for x, I'm going to get 4 times 2, which is 8, take away 5, which is now going to be 3. And I'm also going to plug in 0. If I plug in 0, 4 times 0, take away 5 is negative 5. And instead of solving the last problem that I had, we're going to solve this one instead. And so you guys are going to end up doing the same thing on your particular problem. You're going to do a little bit of a u sub, and after that it should come out being a little bit more relatable to the table. For your next problem, you're leaving behind the table completely, and instead of looking at this problem from a table perspective, we're looking at it from a function perspective. And I'm asking you to find the instantaneous rate of change using an actual graphing calculator. Once again, 1 point for the answer, 1 point for the interpretation. Okay, so let's go ahead and jump into that. So a good one to look at for this would be 2014 Part B. Let's go ahead and read it. It says grass clippings are placed in a bin where they decompose. For 0 to 30, the amount of grass clippings remaining in the bin is modeled by this function here, where A of t is measured in pounds and t is measured in days. Those units that they just gave us there are kind of important. It says here, find the value of A prime of 15. Using the correct units, interpret the meaning of the value of this in context of the problem. So now the first thing we're going to have to do is we're going to have to punch this formula here into our graphing calculator, right? So let's go ahead and do that. Here is the software that I sent to you guys earlier last week. So I'm going to go ahead and push y equals, and I'm going to go ahead and type in the function there. We have 6.687, and then it's 0.931 to the t power. Which we're just going to use x for that. We're going to go back to the home screen now. And the problem's asking us to find a prime of 15. So what that means is we're going to basically be finding the derivative value at x equals 15. So we push math, and you guys can see my buttons that I've been pushing down here as I go. We push math, and then we're going to push 8 for the derivative, and we're going to go ahead and type in derivative with respect to x. Now really when we're doing our problem, we're doing it with respect to t, but our calculator is doing everything in terms of x, so we'll do that. We're going to bring up the function that we typed in earlier. Going to vars, scrolling over and pushing 1 and then 1 again to select y1. And then we're going to enter the point at which we want to find the derivative, which was 15 for this particular problem. And there it is. So it's negative 0.164. Remember, you're always going to be rounding to the thousandths place. Negative 0.164. But we're not quite out of the woods yet. We have to interpret this. So what does this mean? Well, the derivative, as we saw back in question 1, it's a rate. And so what it is kind of like the A value, the input value. So it's pounds per day is what we're looking at. And it was negative. So if I were to interpret this, how I would interpret it is I would say the amount of grass at t equals 15 days is decreasing at a rate of negative 0.164 pounds per day. And there it is. So we have our input units, we have our output units, and then we have the context, the fact that the amount of grass is decreasing at that time. There's your 3 components of a good interpretation. All right, the last question that we're going to look at for your FRQs is 5. Find the average rate of change of B of t on the interval from 0 to 60. Indicate the units of measure. This one's only going to be worth 1 point, and you have to include the units also to get the point. All or nothing. So let's go ahead and see how do we do that. So going back to that same FRQ we just did, we're going to look back now at part A. It says find the average rate of change on the interval from 0 to 30. Okay, well this is once again a lot like the very first question that we did on our FRQ set that we were working on today. An average rate of change on the interval from 0 to 30 would look like this. A of 30 minus A of 0 all over 30 minus 0. Now the bottom is obviously 30, and the units there is we're talking about in this particular problem days. That's 30 days. Now on the top, though, I'm going to just plug these numbers into my calculator to find the outputs to save myself some trouble. Matter of fact, I can plug in quite a bit of it all at once and just get it done with. So bringing back my calculator here, let me clear out these drawings. I'm going to go back to my, I'm actually already on my screen. So I'm going to bring up my variables. I'm going to bring up my function, and I'm going to select y1. I'm going to plug 30 into that function, and I'm going to subtract from that what I would get if I were to plug in 0 as well, and equals. So we have negative 5.904. Now, I'm going to keep that value on my calculator. I don't want to round that yet. I mean, I'll write it down here on my paper, but for now, we don't want to get rid of that. We're going to keep it. So negative 5.904. And what that is that's measured in pounds. Okay, so now what we're going to do is we're going to go ahead and actually just solve this. Negative 5.904 divided by 30, but I'm not going to use negative 5.904. I'm going to actually use the number that was on my calculator. We don't want to round until we get to the very end. So we're going to take the answer that we just had there and we're going to divide it by 30, and we get that. My final answer is going to be negative 0.197 pounds per day. And that's all they need. They didn't ask for an interpretation this time. So my answer will be negative 0.197 pounds per. Okay. And so that's the end of our little FRQ practice.